Young people! In the house. Welcome back, guys. You know what we're doing. Take care of those handouts for you. Shout out to our sponsors, of course. And what do we got today? Looks like chapter 6, lesson 3. The objective today inside of the textbook is solve system of equations by using elimination with addition. Solve system of equations by using elimination with subtraction. Sounds good. So students will be able to swap out. Solve system of equations by elimination. Concept is systems of linear equations, and of course, the skill is solving. I kind of don't like the two separate in the book, but I understand. Great job. Separating when you add to eliminate and when you subtract to eliminate. And you guys are going to catch on real fast. Let's get this bad boy started. All right, guys. Looks like we got a full handout. And we love it. Using addition and subtraction. So, one thing we want to start off talking about, guys, is recognizing opposites. The opposite of a positive is a negative. So, I think we're going to jump right into it because in the first equation, system of equations, the first one looks like x minus y is equal to 1. And our second equation, x plus y is equal to 3. Do you see the opposites? Yes, you do. There's opposites in the y term. And what we mean is negative y and positive y will eliminate each other. So when I add, and that's what's happening here, guys, we're lining it up and it's adding. So x plus x is 2x. Negative 1y and positive 1y will cancel each other. So easy enough, you see you have a solution for x. You can't be done because if you don't have a solution for y, you didn't finish the problem. So in every single one of these, we're gonna get a coordinate point. And as quick as you can, what plus y is equal to 3? Well, 2 plus y is equal to 3. So therefore, y must be 1. And you got your coordinate point. We're gonna go ahead and write that as a finished coordinate and box a beautiful answer. And guys, what's really cool about this handout is it doesn't say check, but we can really do a check real fast. X minus y equals 1. 3 minus 2. Boom. The other one, of course, what is it? X plus y, so 2 plus 1. I'm sorry, 2 plus 1 equals 3, and of course, 2 minus 1 equals 1. Second one's already started. Opposites in the x term now. So of course, when you add y and y, you get 2y, so 2y equals 12, y equals 6. Going back to the next equation, you use the top one, but why deal with the negative? X plus y equals 11, so a real simple one here. What plus 6, what plus 6 equals 11? You can show the inverse operation here, but I don't think I will. I'm just gonna say, well, there it is right in the beginning. X has to equal 5, box my answer. And of course, x equals 5 is not the answer, right? The answer is the coordinate point, so circle it. Oh yeah, little red to show the one step. I love that. Nice big box answer at the top. Coordinate, 5, 6. And again, guys, if I were to plug in negative x plus y equals 1, okay. Well, a negative 5 plus 6 will equal 1, yes. Then the bottom one, of course, x plus y equals 11. Well, 5 plus 6 equals 11. So that right there was a visual check. You just looked at it, right? Plugged in the two numbers, and that's right. Good, it's out of there. Let's get the new stuff in. Nothing new, except it looks a little more challenging. We have coefficients, real important. With number 3, equation 1, equation 2. A system of equations is 2 or more equations. So we only got 2 algebra 1. Wait till Mr. Rossetti gets here with algebra 2. All right, so x plus 4y equals 11, x minus 6y equals 11. We don't have any opposites here. X and x are both positive, and positive 4y and negative 6y are not opposites. Different signs. But if the x was negative, and there you see, I made it negative by multiplying by negative 1. So the negative 1 times x, the negative 1 times 6y, and the negative 1 times 11. Don't change the top, because you don't need to. There will come a time where you're gonna have to change the first solution and the second solution to get opposites, so you can eliminate. But in this one, guys, I just have to change the bottom. So, got my opposites, and this is where we would subtract, right? Even though I put addition, I put that negative, which basically means I'm subtracting in their minds, right? 4y and 6y gave me 10, y. We had opposites, so gave me 0, y equals 0. Going back to the original system, picking one of the equations so that I can solve for the other variable. So I'm solving for x now. X plus 4y equals 11, so x plus 4 times 0 would equal 11. And then of course, 0 times 4, 0, x equals 11. Again, give me a nice boxed answer. And I am feeling good. All right, guys, so as I look at number 4, this is be a happy face. And I say it's a happy face because I see opposites. First term in the first equation, negative x. First term in the second equation, positive x. That's why I'm happy. You see the happy face. And so, boom, bang, pow. 3y and 3y is 6y. 6y is equal to 24. So what times 6 is 24? 4. So it's pretty fast when you understand the concept, right? And the concept is just add and solve. But you can only add them if it's going to eliminate one of your variable terms. So in this case, we eliminated the x term, which ended up giving us y equals 4. I chose the second equation, the bottom one, x plus 3y equals 18, so x plus 3 times 4 equals 18. 3 times 4 would be 12, so I need to say x plus 12, so please make that a 12, and then it's equal to 18. So again, in my head, or showing the inverse operation, the opposite of adding 12 would be subtracting 12, x would equal 6. And now that I have x and y, nice box to answer at the top, and we're ready to move on, right? So again, guys, I call it adjusting. And what I mean by we have a first equation, we have a second equation. Do I need to adjust the top one so I can see opposites? Or do I need to adjust the bottom one so I can get opposites? Or do I need to adjust the top equation and the bottom equation because I need to? Like, it's literally understanding what you need to do so that you can cancel out the x terms or cancel out the y terms. So for number 5 here, I don't see any opposites. I see the same sign and the same coefficients, 3x and 3x, but that does not eliminate the x terms. So in my brain, I go, well, let's make one of them negative. How do I make a positive and negative? Multiply by -1. Chose the bottom equation, this time just a negative. No need to put -1 if I could just put negative. And first equation, rewrite just as it is. 3x plus 4y equals 19. Second equation, -3x minus 6y equals -33. Keep it moving, right? Now it's good to go. Add it up, the top and the bottom. First terms eliminate each other. The second terms add up to a -2y. And then of course, 19 minus 33 is equal to -14. And of course, -2 times 2 is -14. Pause. That's why we check our solutions, right? So guys, we're gonna keep watching this problem and we're gonna see what happens because I don't know what BMB is doing. He's making a mistake and it happens. Let's keep going. We see right there, everybody knows 2 times 2 is 4. My brain must have thought, I guess I want to put 2. So let's get started, see how this ends up. It looks like I'm choosing the top equation to finish the problem, meaning if you know what x is, go find out what y is. 3x plus 4y is equal to 19. So 3x plus 4 times 2 is equal to 19. 3x plus 8 is equal to 19. Subtract 8 from both sides, right? So it ends up giving me now 3x is equal to 19 minus 8, which is 11. And then my brain kind of goes, well, fractions are okay. but we made a mistake earlier, right? So, great job of working through the problem. Even if you make a mistake adding, subtracting, multiplying, taking the square, anything, you still muscle through, right? So a great example of how to make a mistake and still keep going. That's right, I kept going. And you see how long it's taking me to get this final answer. I guess I felt a little uncomfortable with 11/3, but we're good. So here we go, guys. Number 6, I'm happy. Am I happy because of the x terms, or am I happy because of the y terms? Well, you tell me, because there's the happy blue face, and I'm happy because of the y terms. 4y and negative 4y are opposites, they will cancel. It's set up for elimination. Didn't have to do a thing, but smile and cancel. 2x is equal to negative 16, so therefore x will equal negative 8. Now that I know what x is, what's y? X plus 4y equals negative 8. So negative 8 plus 4y is equal to negative 8. And I go, hold on, if I add anything to negative 8, how is this going to be anything other than negative 8? Oh, it must be 0. So we end up adding 8 to both sides. That's why the negative 8 disappeared on the left and the negative 8 disappeared on the right. 4y is equal to 0, therefore y must equal 0. And again, guys, a perfect time to check. If you are doing this for class and your teacher is requiring you to do checks, maybe check 2 of them, check 3 of them. Definitely the skills is going to enhance your algebra ability. So, let's get all this out of here, guys, because we got a lot more to go. But what's cool about it, guys, is nothing's changing. We're still using our eyes to see what we need to do. So for 7, do I need to do anything? Do I need to adjust one of the equations? No. There it is. 3x plus 4y equals 2, and 4x minus 4y equals 12. So would it be the first set of terms, 3x and 4x, or the second set, 4y and negative 4y? Awesome, right? And, oh, I actually know what 7 times x equals 14 is. Good, it's 2. And keeping it pushing. Once I found out what x was equal to, I decided to choose the first equation. 3 times 2 now, not 3 times x, I know what x equals. Gave me 6, so 6 plus 4y equals 2. Subtract 6 from both sides, that's where the negative 4 came from. And then of course, what times 4 gives me negative 4? It's gotta be negative 1. So again, number 7 was clean and ready to go. Number 8 is not clean and ready to go. So number 8 is where I'm checking with my students and my viewers, would you know which one to adjust? Would you adjust the top equation, equation 1, 3x minus y? Or would you adjust the bottom equation, negative 3x minus y? Neither, they're ready to go. And y will equal negative 2. So, when you see opposites, elimination is your go-to choice, right? So here we are, guys, with 3x now, minus negative 2 is equal to negative 1 because we plugged in for y. I chose the first equation. So 3x plus 2 is equal to negative 1. This is our 2-step, right? We're going to subtract 2 from both sides. Gives us negative 3. And then, of course, divide 3 into negative 3. You get that negative 1. So, looks like 7 and 8 were what we would call happy ones, right? Smiley face. We had opposites already ready to be eliminated. That's not going to happen, except for maybe once or twice on a quiz or a test, because they want to see who has the ability to adjust to eliminate one of the variable terms. So, with that, what do we got? We got 9 and 10. Gotta adjust 9. I do not have to adjust 10. Why do I have to adjust 9? 2x and negative 5x. Nope, they won't eliminate. Negative 3y, negative 3y gives me negative 6y. It will not eliminate. So, will I adjust the top or the bottom? Looks like the bottom. Got a negative in front, meaning everything inside goes to the opposite. Top equation, 2x minus 3y equals 9. Bottom equation, positive 5x, positive 3y, and negative 30. Why? Because the opposite of a positive 30 is a negative 30. Now I'm ready to eliminate. And I'm going to end up with just x terms because I set up to eliminate the y's. 2 and 5 give me 7. Of course, 7 times what is negative 21 is going to end up being x equals negative 3. Again, going back to either the first equation or the second equation because I got to find out what y is equal to. 2 times negative 3 now, minus 3y is equal to 9. Negative 6 minus 3y equals 9. When you add 6 to both sides, negative 3y is equal to 15. Y is equal to negative 5. So guys, this is as we're getting the final solution, you're noticing I'm solving equations 1 step, 2 step done. 1 step, 2 step, 3 steps done. So there's a lot of solving when you're dealing with systems. It's just what method are you going to use. So any adjustments for 10? Nope. I see my opposites with the y term. Kind of funny that 4 and negative 4 give me 0. Negative y and positive y give me 0. So 3x, because 1x and 2x must equal 0. X is 0. It's going to work out as long as you know how to solve a 2-step. Very rarely will you have anything more than 2-step with these solutions. Systems, I mean. I'm decided to plug back in. Again, guys, nothing complicated about that. Be sure to use your parentheses as you're seeing that I'm doing consistently, right? Final answer is up there. Go ahead and get it in. 0, negative 4. So again, guys, as we haven't taken any time to write down any checks, we did do a verbal check earlier, and that's just something that I'm going to keep reiterating. There's 3 methods to solve. You got graphing, elimination, and substitution. So this is the last one, elimination. Chapters 1 and 2 were graphing. I'm sorry, lessons 1 and 2 were graphing and substitution. So, happy face for 11? Nope. We're going to have to adjust. So, top equation, 3x minus y is equal to 26. And the bottom equation, negative 2x minus y is equal to negative 24. Looks like the negative y and the negative y are the closest. They have the same coefficient, but one of them needs to be positive. So change the negative 1y to a positive 1y by multiplying by negative 1. Top equation stays the same. 3x minus 1y is equal to 26. Second equation is now positive 2x, positive 1y. Might as well put the 1 is equal to a positive 24. Go ahead and get my line, add those 2 up, and which will eliminate the y terms. That's what we want. 6x plus 0 now is equal to 50. 6x, I didn't think so. Get that out of there. 3 plus 2 is 5, not 6. I must have been thinking multiplication, but at least I caught that mistake right. So 5x plus 0 equals 50, 5x equals 50, 5x equals 50, x must equal 10. And if x is 10, then I can tell you what y is. 3 times 10, or 3 times x, right? Minus y is equal to 26. So 30 minus y is equal to 26. When I subtract 30 from both sides, it eliminates the 30 on the left, and on the right now, 26 minus 30, negative 4. Y is equal to positive 4. Just had to divide both sides by negative 1. Final solution for number 11, x is equal to 10, y is equal to 4. And here we go, guys. Again, if I wanted to do a check, I would take the x and the y value, plug it into the first equation, verify it's true. Plug it into the second equation, verify that it's true. Number 12, I'm happy because there's no adjustments happening here. And again, guys, what do we mean by an adjustment? Are you going to multiply the top equation by something so that you can see opposites with the x terms or the y terms? Or is it the second equation you need to put brackets around and multiply by negative 1 or negative 2 or maybe even positive 5? You can always multiply by any number to adjust your equations. Just keeping it balanced, right? So, you guys were watching while I was talking, and of course, what do we get? We got 4x plus 0 because the y terms are already opposites, as you can see. 4x equals negative 4, so x equals negative 1. I'm going back, plugging back into the, looks like the top equation. So 5 times x minus y equals negative 6, getting a final solution. negative divided by a negative is a positive, so boom, bang, pow. Looks like we got -1 and a +1, xy. So, I think we're getting to the bottom portion, guys, but we've done 12 problems, and all 12 have been pretty much the same thing. Only thing that might have made it more complicated was us having to, adjust either the top equation or the bottom equation. We have not had to adjust both yet. But for 15 and 16, looks like we haven't changed anything yet. Positive, 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 meaning positive 7x, positive 7x. Positive 4y, positive 2y. They're not even different signs. So, but the coefficients are the same. So since I have a 7 and a 7, just make one of those 7s a negative, and then you got opposites. So you're noticing here's the subtraction to eliminate, and the only reason why we're calling it subtraction is because it's a negative. But bottom equation now, -7x minus 2y is equal to -8. You can add, you can do it from here, all right? We gotta do a little dividing too, but 2 and -8 gives me -6. The x terms cancel. 4y and -2y gives me 2y. So 2y equals -6. Y equals -3. And now we go back to the original system. Are you picking the top or the bottom? Looks like we picked the top. So 7x plus 4y is equal to 2. 7x plus a -12, or just 7x minus 12. You see that? It's the same thing. Go ahead and solve your two-step. Add 12 to both sides. 7x is equal to 14. Therefore, x must equal 2. There's my solution. Box. X is 2, y is -3. And again, guys, we're going to do the same thing. And this is where you could possibly pause, try to see if you can figure out number 16 on your own, and then just come right back, right? And I'm still not happy, or am I happy with number 16? Happy face, it's ready to go, guys. You have opposites right there. A -5y and a +5y will eliminate each other. Hence the title of the lesson, Elimination Method. Right. 2x and 4x give me 6x. 6x equals -24, so x equals -4. Going back to the original, 4 times -4 now. I chose the bottom equation, didn't want to deal with a -5y. So 4 times -4 is -16, plus 5y equals 4. Go ahead and solve it. You guys got it. And a nice box to answer at the top. And guys, I believe we're going to move on to the word problem section of this. And it's good. So, recapping again, guys, the whole lesson was solving equations. The only thing is we have 2 equations and we have to solve for both x and y. And did a great job with it. As we take a look at the last bit, I don't think we're going to do all of these, but let's definitely get you set up. And when I say set up, what does 17 say? The sum of 2 numbers is 28. So, we're going to go ahead and say the sum of 2 numbers. Those numbers are x and y. They're variables, right? And equals 28. Their difference is 4. So x minus y equals 4. There's my system, and I see opposites in the y term. Same thing here, guys. 18. Find the 2 numbers whose sum is 29. So x plus y equals 29. Then, of course, the difference is 15. So this time, x minus y equals 15. And again, do you see opposites? Yes. So you going from words to numbers and then just doing the same thing we did 16 times, right? 19, the sum of 2 numbers is 24, so x plus y equals 24. Their difference is 2, so x minus y equals 2. For 20, it looks like find the 2 numbers whose sum is 54. So again, 2 numbers whose sum is 54, x plus y equals 54. Whose difference is 4, x minus 4 equals 4. So they are literally having you just practice over and over. And again, I'm glad you came so you can verify that the word are matching the system that I'm writing. Last one, guys, I think I'm actually going to take care of one of these for you. Let's knock it out. 2 times a number added to another number is 25. So 2 times x plus y is equal to 25. The second equation is 3 times the first number, so 3 times x minus the other number is 20. So what's cool, guys, is you can see right there, plus y and minus y. Those are our opposites, right? So whether it's 17, 18, 19, 20, 21, they all are set up for the elimination method. So let me do the last one, and then you guys can take care of the rest of them, right? So 2x plus y equals 25, 3x minus y equals 20. I'm gonna set up, happy face, and let's get it. Once I draw that line, I know I can add them up. The first terms add up to 5x. The second terms eliminate each other. So 5x is equal to, looks like 45. So x must be 9 because 5 times 9 is 45. Now that I know what x is, let me go back on up, arrow across, 2 times x, which is 9, plus y equals 25. So 2 times 9 is 18. So what plus 18 is 25? That'd be 7. So I will subtract 18 from the left, subtract it from the right. Y is equal to 7, right? There we go. Good, box, go. All right, guys, circle and box your coordinate point, right? And that's about it, guys. So as we get that final answer, once again, guys, 3 methods to solve a system equations. Graphing, where you actually graph the lines. Secondly, with substitution, where you circle and point. And then the last one, we just took care of elimination. Guys, I hope you enjoyed it. Wait, that's it. We're done with systems. No! See you in the next video.